Hello there again. This is Al. I'm still working a little bit on that problem, but I thought just in the meantime I'd throw in this little very quick review of something to do with the title of this video, which I hope should be saying what's in a name. And I don't know if you've been following these tutorials and watching me press the compile button over and over again, you would have seen all of these lines: test me, test me, test me. And these are all things to do with like files, file exists, and so on. Get file size. And why am I so concerned about the fact that these, they look perfectly fine functions. How hard is it to just, go ahead and pass a file to one file that exists and one that doesn't, and see if it works, and you're done? Well, that would be sort of true, except, well, for most of these things, it really doesn't matter that much. But here's the thing. These are things that have to do with path names, like path names. A path. Well, I want to keep that one. Here's a path. I don't know. No. Hello, okay. So that here is a path name. So these are functions to do with path names. And the thing about path names is that it's a very poor identifier for something like a file or a directory on your system. In fact, it's one of the worst. In one of my other projects, I have an any file class, okay? And I don't know, I guess I could go there. It's still around. And it uses the file name so that if somebody tries to open another instance of one of those any file things and it's the same file, then instead of opening a new one or giving an error, I just link them together. It will give you the same file. And in fact, that speeds things up a lot. Where's my any file? My any file. So, see, I have this map. Now this is a map of like string to one of these any file interface type things. There's an interface type class. Where is that defined? It's a smart pointer. Okay, that's all. So it's a thing that is a reference counter. It has a full path name in it. Well, I think is a full path, and then I have a map of path name to one of these pointers. And so if you try to open a thing and it's the same file name, then you get the same thing. And that makes these file actions quite speedy, and you can pass these things around. And and it's all great. However, I knew right from the beginning that this file name is not a unique identifier. And for instance, there's a thing that you can do called subst. You can substitute drive letters for paths, right? And so I invented a function called compare path names or something. Util. Split path, or it's compare file names. And it's quite an involved procedure to compare two file names and see if they actually point to the same file. But I've discovered recently that there's a faster way. Full name, here, compare paths, okay? Two paths. Well, if they're equal but different in case, then they must be the same file. Even if they don't exist, they're going to point to the same thing. That's okay. Now, I extract file name and extension from the two paths, okay, if I can. Now, if the first one doesn't have any wiggles, that means it's not a contracted 8.3 thing, and the second one doesn't contain any wiggles, then there are no wiggles. So I'm actually asserting that these two functions are getting rid of the wiggles for me. If there's a reason, remove the asterisk. Okay. So the comment here is if there are wiggles, then the problem's not here. Somewhere that should have been fixed at this point. Okay. Now I'm still handling this error. If it's not true, if this one doesn't contain wiggles, oh, wait a minute, hang on. Yeah, no, that's true. If not, file name 1 contains wiggle, and not file 2 name contains wiggle, Yeah, I'm assuming this is true. Okay, well, suppose this just say if true. If it's not the same, if it's not true that they're equal case insensitively, then they're not the same file if they don't contain any wiggles. Now, why is that true? Folder name. Folder names may differ and point to the same directory. True. However, the file names, all this is the file name without the drive and path or anything, have to be identical once the directory has been resolved, assuming there are no wiggle issues. That's false, turns out. Okay, assuming that doesn't happen, now I'm getting the full path name. It's part of assume I've done. Checking if either one or the other exists. If this is like an XOR, if one exists and the other doesn't, they certainly can't be the same file name. Okay, so Now, either both of them exist or neither of them exists. So if this exists, then the other exists. File name may be contracted only if it contains a wiggle. Neither file contains a wiggle. And we know neither is an 8.3 format. So that's just, well, so there's no need to convert to 8.3. See, my method here was to convert to 8.3 DOS and then use that comparison because it's easier. Okay, and then so now I'm getting the short path name and calling that the full path. Now, now the thing about the short path names is that they're always in uppercase. So actually I don't even need this equate. And if their short full path names are identical, certainly they must be the same file. However, they may not be. Now, suppose that the first drive letter is equal to the second drive. So we have the same drive and different file name. No need to resolve since it gets short written. And this is also false. This function doesn't work. I'm going to show you in a minute. Then I do a resolve the drive letter into the physical device. Okay, now what that turns into is things that look like, where is it now? Well, it's like slash device 0. So it will look like a resolved thing will look like device 0 or volume something. What does it look like? I want to see one. Come on, show me one. I don't want to have to run through it. Too bad. How can I do it quickly? Maybe I can find it without. No. It's like volume or device or doesn't matter. Here's the problem with path names. Okay, now I set this experiment up first to just do it explicitly, just to make you aware of the fact. First, I won't print anything out. First, take a look at this list of files. Okay. Now this happens to be the contracted form of this file name, the 8.3 version. Here's an MP3 file on a drive called K. It looks like that. Here's another MP3 file in a J drive called Song. Here's another one on the D drive under Debug and Song. And here's another one under D temp called something mutable. Here's a weirdo wiggly thing. Here's another thing. One drive, one another drive. Okay? Now I'm going to show you that almost all of those files are the same. The way to find out, and I don't know if this works on anything besides an NTFS volume, is to get the file's unique identifier. Now, the unique identifier for this file name, okay, assuming I've worked it out properly, is this number, 6 blah 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 20 blah blah blah, and that's the same as this number, so therefore these two files are equal, are the same file. Okay. 3b 2b. So these two files are the same file. Different drive letter, different folder, different file name, completely everything different, but those are the same file. And that happens to be the same as this file, which is on another drive, in a different directory. Similar to this one though. Oh, and here it is again, same file. dtemp test 3b ed blah blah blah. Same file, different name, different drive, same drive as this one, okay, different folder, different file name, same drive, same file. Here in the root of L, a file, same file identifier as this. Okay, so this file name thing really has nothing to do with what is the file. Okay, now I'm going to add another piece of information to this. And that has to, see this. I was aware of this possibility too when I was writing that compare paths function, and I knew it was always going to be wrong. But now I think with this thing that I've discovered, this extended attributes, I can find out more. Well, for one thing, I can find out if two things are the same, and I can find out the reason why they're the same. These two are the same because these are not only the same file, but they're also in the same directory, if you like. It's just that this is a different way of writing the directory name, and that's because they're not linked to anything. Okay, now a link is a thing. I even wrote a program to do this. For instance, take this. Let's take a big directory here. Okay, 41 gigs. All right, that's on my D drive. Let's do a little okay, 169 gigs. Now if I'm going to make a copy of this directory, and you're going to see that I won't lose any drive space. I made this program for the specific purpose of having things in two places at once. Let's see, I want to put it into temp. Okay. So the size of my drive hasn't changed. And now go to temp. And here's that same folder. These are not new files. They're links. That's why they got the little link thing on them. If I modify them, right, then they'll become their own files. So if I wanted, for instance, if I wanted to drop some drive space, suppose I rename these. This should go down. Currently 69.7. Oh, dude. It's still got the link on it. Okay, they're still the same file. But certainly if I modify them, but I don't have a big enough, oh well, okay. CD echo A into their dot adding. Okay, see? Now that definitely changed I increased, I think I've destroyed both of them. That must have been a triple link or something. I don't really care about those files anymore, but let's go to the original. No, that was one of these two. So how did my drive space go up? Oh. That's the temp one. Hello.abby, and there is only 4 bytes. And I gained a whole bunch of space. And I have no idea why. But anyway, now I can take this directory. Delete this directory. This is the one I just created. And in Windows 7 you got to be very careful with the delete key, because it doesn't always. Too large for recycle bin, yes. I'm still okay with this. I haven't lost anything. Oh, I did lose that one, see? See? They were linked and they remained linked, and this one is now just dead. Okay. So, maybe there's different ways. Sometimes when you change one, it splits and you get a second version. And it probably depends on whether you're using an editor or using the piping. An editor might be smart enough to say, to do like what I've done, and see that the file has links, it's linked to something else, right? And decrement the reference count, unlink it from the rest of the chain, and then make a new copy, right? So that the rest don't get all messed up, like what I just did. You know, I thought I could edit that file. You know, it's a file, it's my file. But it wasn't, it was somebody else's file too. And that's true of these. Now, some of these are on substituted drives. And I knew about that. And that's also another thing that you can work out with this resolve DOS device. You turn a drive letter into a special kind of identifier that identifies a physical device. There's also a function that I'm not displaying the output of, and that's this. If I change all these printouts to, instead of using the path passed in, to using what this returned. Well, is that the only place I print? File name, I guess so. You'll see that this does normalize things somewhat. For one thing, it gets rid of the wiggles. It also correctly puts the case, with the exception of the drive letter, it puts the case correct. That is, this comparison from here to here, right, if they're the same length and same letters, will have the same case. All of these will have their correct file name. So this one, that little one with the wiggle, became logo letters, and now you can look here. So it's my guess that L is a substituted drive for this path, blah blah blah, here. And in fact it is. Okay. But anyway, it doesn't matter. It makes no difference with what these letters say. All that's important is whether or not the file ID is the same. Now, I haven't tried a directory. I'm not sure what I get. Let's try a directory. I'd like to try one of those. These junction things, which I've always heard about. Where? I want to do this. I want to specify this. I'll take this text. Assuming this is treated like a directory, it's called recent. So I would take this /recent, right? Now I think that's going to return to me a junction. Info get file by handle invalid. So I'm thinking of it like if I said pictures, it should work. Get file information by handle. How do I open again? Open existing. See, now I have another function called isDirectory, which is in that list of test me. Test me, get file size, file exists. Get long path name. Do I have the long path name at this point? Is that what failed there? File name C is now in picture. No, it got to here, so it does exist. Okay. I just couldn't get the information. See, get long path name. Watch. To prove that get long path name has to do with the actual drive, you know, I'll change the case of this. And you'll see it'll convert it to the proper case. See? So that, okay, now why couldn't I get the file information? The handle is invalid, and how am I opening it? And how should I open it? Here, I'm not using the EX version. I'm using create file. Oh, I see. I'm saying attribute normal. I have to specify the. I see. Okay. So see why you have to be so careful with this? I might have used this to check to see if the thing exists, and I would have come up with the wrong answer. This gave me the correct answer in terms of the thing existing, and whether or not it's a directory, I think I can find out too. I'm saying open existing. Normal only if used alone. Wait a minute, but oh no, the handle was in. What was the handle? Sorry, I didn't expect to actually have it fail on me. Okay, create file failed for that. And the reason was I should have printed out the reason. Oh. So stupid. Invalid handle value. Is that the error return? Yeah. The reason is not equals unsafe, promoted to handle equal to given constant. One of those things about macros, huh? The reason, access denied. Now why am I getting an access denied? I wonder. So that's something to think about. And the other thing is about these junctions. Now you know how I did that linking of two directories? Now I did that by creating a new directory, a brand new directory, and then walking through the list of files and then making hard links. In fact, you can make hard links. The H link. Man. Here, make link. You can make a symbolic link. A symbolic link and a hard link. Create a directory symbolic link, otherwise it's a file. A hard link those are the things that I was making. And then a directory junction. I don't know what that is. And see, I thought that was the equivalent of a hard link directory. But now there's this, but what's it? Oh, I see. D for directory, otherwise file. Okay. H for hard link instead of symbolic link. Now, hard link means that adds, certainly I know that means it adds a link in the attributes, but I'm not sure what a symbolic link is. And then it can create a directory junction, which I thought was like another, like a thing that looks like a directory, but it really refers to a different directory. And I think that's probably what it is. I'm going to try it. Let's try it for fun. Somewhere else. A D. Somewhere safe. Temp. Okay. Let's suppose, is there anything in output? Okay, there's a couple of things in there. I don't want a subdirectory too. Okay, lots of stuff in output. Now I want to make a what was it called? A H link? Make link. Make link. Slash. I want a junction. Link, the new symbolic link name comes first. So let's say let's try a completely different folder. Where is it? Somewhere I don't care about. HLA, good, okay. And a name, I gotta give it a name. Output. D temp output. I mean, we can make it long. Who knows? Try it all. Okay, so assuming that's going to make a directory, the target, relative to that path that it refers to. So it would refer to dot, would bring it back to HLA root temp. Okay, this is interesting. Wow, look at that. It's got all the same stuff, but it's a junction. See that? And there's where it really refers to. Cool. Now that did in one step what my little program did to do in a lot of steps, and not only that, but this is not a new directory. It's an alias in a different directory. You probably can't. Usually, you can't change volumes because it just doesn't work that way. The reason those other like K or whatever, the reason we're in the junction. It's not the junction, right? But if we can't, can we get there? No, it's HLA. This K is a symbolic point. So I'm going to get rid of them all. I wonder what they all are. G. Oh. J. L. Okay. Better. So there you go. Never use path names. As far as getting the attributes of a directory, don't know yet. Something I gotta figure out. This is not the way to open up a directory. You can get its attributes. Create file is a very intricate and detailed function, and you've got to be very careful about getting all these flags right, and making sure to use the wildcard thing, getting the names right, and getting the share mode right, and security access right, and blah blah blah. It's a function that requires a lot of thinking, and that's why you see all that test me stuff. I gotta run tests for each of those functions for everything I can think of, like a substituted thing, a junction now I've added to the list, a hard linked thing, 8.3 versus long format, and so on. Relative path versus absolute path, relative path to a subst, of a junction, right? You can see how many possible ways there are to try and mess those functions up. And I gotta test them. Okay, see you. Bye.